this section we will be working with properties of exponents. Now at the top of the page you see some basic properties of exponents involving 1 and 0. N to the first power, the idea is any number to the first power will equal itself. So n to the first power is equal to n. What this tells you is if n is equal to 5, 5 to the first power would be equal to 5. Any number to the first power is equal to itself. Flipping this around, 1 raised to any power. This could be 1 squared, 1 cubed. Any power of 1 will give you 1. Now with 0, any number to the 0 power will give you 1. Any number at all, any number except 0. So this rule only applies for real numbers that are not 0. So any number to the 0 power will give you 1. The last one here, 0 raised to the nth power. Now any power of 0, 0 squared, 0 cubed, will give you 0. So 0 to any power will give you 0. Any power that is except 0. All right, this property only applies when n is not equal to 0. So example 1 refers to these properties. So evaluate and simplify each of the following, starting with 5 times x to the 0. Now order of operations states that you need to work with the exponent before the multiplication. So we need to work with the x to the 0 before we multiply by 5. So over here I'm just going to copy down the 5. X to the 0, any number to the 0 power, is 1. So we have 5 times 1, which is 5. Now the next part here, we have 2x plus 1, in parentheses, the whole thing raised to the 0 power. Now the rule is anything raised to the 0 power is going to give you 1. Anything. So even though we have an expression and not a number in here, the result is going to be the same. Any number to the 0 power is 1, so this raised to the 0 power will still give you just 1. This last one we have a to the 0 plus b to the 0 plus c to the 0. Any number to the 0 power is 1, so a to the 0 is 1 plus b to the 0 is 1 plus c to the 0 is 1. Adding these up, 1 plus 1 plus 1 gives you 3. Now next we will be working with the multiplication property of exponents, and it is stated in general terms here. A to the m times a to the n gives you a to the sum of the two exponents. The idea is if you are multiplying two expressions that have the same base, then the result is that base raised to the sum of those exponents. So to give you an idea how this works, starting with some examples, if you have a squared, writing this in expanded form, a squared is equal to a times a, and let's also use a cubed. A cubed would be a times a times a. Now what you're going to see in these types of problems will look something like this, a squared times a cubed. Now writing this out in expanded form, a squared was a times a times a cubed was a times a times a. Putting this together, you have a multiplied by itself 5 times, so that would be a to the 5th. Applying the multiplication property, I'm going to write down the same problem here, a squared times a cubed. What this property tells you to do, keep the base, add the exponents. So you would have, or wind up with, a to the 2 plus 3, which is a to the 5th. Gives you the same answer. Now a little caution here, this property, you have to be very careful, this property only works when the two expressions have the same base. If you were to be evaluating, let's say, a squared times b squared, expanding this out, this would be a squared is a times a, b squared would be b times b. There is no way really to combine that other than to just put it back together as a squared times b squared. This property only applies when you're working with the same base, and that's going to come in to example 2. Looking at example 2, we're applying this property. We have n cubed times n to the 9th. Property says we add the exponents, so we have n to the 3 plus 9, which gives us n to the 12th power. For the next one, we have b to the 5th times b to the 4th times b. All of these have the same base, so we're going to keep the base and add up the exponents. This is going to be b to the 5 plus 4 plus, looking up to the properties at the very top of the page, if you just see b, you can always imagine it's raised to the first power. So you have 5 plus 4 plus 1, which gives you b to the 10th power. Now this last one is getting more complicated. We have numbers, we have x's and y's. The trick is multiply the numbers with the numbers and then apply the multiplication property to the like bases. So we're going to multiply the numbers with the numbers, the x's with the x's, and the y's with the y's. So this is going to give us 5 times 7 is 35. Then multiply the x's with the x's. We have x squared times x to the first power, so that's going to be x to the 2 plus 1. And do the same thing with the y's. We have y to the 5th times y to the 9th, so y to the 5 plus 9. Now put it together. We have 35, x, 2 plus 1 is 3, so x cubed, y to the 5 plus 9, or 14. Now the next property of exponents involves raising a power to a power. And in general form, you'll have a to the m, an exponential expression, raising that whole thing to another power. And the result is going to be the product of the two exponents. So what you're going to see will look something like this. You'll have a squared cubed. Now expanding this, whenever you cube something, you multiply it by itself 3 times. So expanding this, this would be a squared times a squared times a squared. Now this, we can apply the multiplication property. The bases are the same, so we have a to the 2 plus 2 plus 2, which gives us a to the 6. Another way to look at it is simply by expanding the whole thing. Rewriting this, we have a squared cubed, and that again will give us a squared times a squared times a squared. Expanding each one of these, a squared is a times a, so we have a times a times a times a times a times a, which is a to the 6th. So example 3, here we have x cubed to the 9th. Applying this property, we multiply the exponents. So we have x to the 3 times 9, or x to the 27th power. The next example here, we have 5b squared times b to the 5th to the 8th power. Order of operations, you work with the exponents. So the 5b squared, we're going to wait to multiply those and work with this piece right here. So this would be b to the 5 times 8. 5b squared times b to the 5 times 8 is 40. Now go back and apply the multiplication property. We have 5b to the 2 plus 40, which is 5b to the 42nd power. Now the next property of exponents we will be working with involves raising a product to a power. In general form, you have a product inside parentheses. Here I have AB raised to some power, and the result is raising each of the factors of the product to that power. So an example would be AB cubed. Now expanding this, whenever you cube something, you multiply it by itself 3 times. So this would be A times B times AB times AB. And looking at these, we have A times A times A, so that would give us A cubed, B times B times B, B cubed. So that's the main idea behind this property. So moving to example 4, we have 5x squared. The idea is you square each factor. So we'd have 5 squared times x squared. 5 squared is 25, x squared. The next one, we have x cubed y squared raised to the 9th power. And the idea is exactly the same. You take each factor, in this case the x cubed, and raise it to the 9th power, and the y squared. Raise that to the 9th power. The result, you have x to the, remembering the power to the power property, you multiply 3 times 9 is 27. Y, you do the same thing, 2 times 9 is 18. This next one, same idea. You're going to raise each factor, each piece, to the 2nd power. So we have -8 squared, A squared, B to the 5th squared. -8 squared gives you a positive 64. Be really careful of those negative signs. It would be a positive 64. A squared, B to the 5 times 2, which is 10. Next, we have 5 times, inside the parentheses, -2 times w to the 7th. All of that raised to the 3rd power. So it's important that you work with the exponent before you multiply. So we're just going to leave the 5 alone for now. We're not going to do anything with that, but we are going to raise everything inside the parentheses to the 3rd power. So this would be -2 cubed and w to the 7th cubed. Again, not working with that 5 yet, just copying it down. -2 cubed is -8. W to the 7 times 3 is 21. Now multiply. 5 times -8 is -40 times w to the 21st power. Last example, kind of combining everything that we've done so far. Here we have 5 into the 4th times -3n cubed, all that squared. So again, you need to work with the exponent first. So the 5n to the 4th, we're just going to hang on to that, save it for later. Raise everything within the parentheses to the 2nd power. So we have -3 squared and n cubed squared. 5n to the 4th hasn't changed yet. -3 squared gives you a positive 9. N to the 3rd squared, 3 times 2 is 6. Now we can multiply. So remember, numbers with the numbers, n's with the n's. 5 times 9 gives you 45. N to the 4 plus 6. So that would be 45 n to the 10th.